Hello again, everybody. Mr. Reeves with you today to work through solving some problems using the substitution method. So we are in the process of learning how to solve systems of linear equations. The first method we learned was solving by graphing. I hope you had a chance to get a lot of practice and watch some videos, maybe even the videos I made. I made 2 videos. If you haven't had a chance to watch them and you need some help on solving by graphing, make sure you do that. But we're moving on now to solving by substitution. In my opinion, this is one of the most challenging things that we do in the area of algebra, at least beginning algebra. And so I hope that if you're struggling, maybe these videos, I'm going to make one on just solving the systems given the systems by substitution, and one where we're going to do some problem solving with it. So all right, let's go ahead and dive in and get to some problems. I'm going to skip on over to the examples. This is page 242, not the examples, but actually the assignment. Page 242, solve each system of linear equations by substitution. So let me give you a quick introduction. When you have two systems, and I've mentioned this before, your goal in solving a system is to find the value of x and y that makes both equations true. So we're looking for an x and a y that makes both equations true. That makes both equations true. All right. And how we find that, one way is to graph the lines, to graph this and that one and see where they intersect. But that's not always the best way, and sometimes you can get fraction or decimal answers that you can't really find from the graph. So a way that works all the time is the method of substitution. Now, something you should know is where that ordered pair is, that same x and that same y make both equations true. So let me just do a quick example over here on the side. Let's say I asked you to find two numbers that added to equal 9 and that subtracted to equal 1. Two numbers that add to equal 9 and subtract to equal 1. Well, I happen to know an answer because I just made it up right now in my head. 5 and 4. 5 for x. 5 plus 4 is 9. And 5 minus 4 is 1. So x and y, x being 5 and y being 4, make both of these equations true. Now there's lots of x's and y's that make this first equation true. I could have done 6 plus 3, right? I could have done 8 plus 1. But then if I did 6 minus 3, I wouldn't get 1. And if I did 8 minus 1, I wouldn't get 1. So we're only looking for the x and the y that make both true. And where that happens, these two will be the same. And these two will be the same. And the reason that's so important to understand is that means that this y and this y are the same. And I'm going to use a different color. This x and this x are the same. So wherever I see this second y, or whatever it's equal to, I can replace the first y with it. Or wherever I see the first x, I could replace it with the second x is equal to. Substitution. You guys are familiar with substitution. You're familiar with substitute teachers. That's when a teacher comes in and tries to teach when the real teacher's gone. Or in sports, right? Someone gets pulled out of a game and a substitute is put in their place. Generally, when you're putting in a substitute, you try to put someone in that is the same or very close to it, right? In soccer, you're not going to replace a goalie with a forward unless that forward's really good at being a goalie, or vice versa, right? You want to replace two things that are very similar. In mathematics, when we substitute, we replace things that are exactly the same. They might look different, but they're exactly the same. And that forms the background for substitution. So here we go. Question number 1 says 3x minus 2y is 9, right? So we're looking to make that equation true. We're also looking to make the equation true, y equals 2x minus 7. But this second equation should stand out at you a little bit. Do you know why? Because it tells you what y equals. It says if you want to know what y equals, then take x, multiply it by 2, and subtract 7. Well, that's what this y equals. Guess what this y equals? It equals the same thing. So this is what I often do when I'm showing students how to do this. I'm going to circle what y equals in the second equation, and I'm going to go and put an arrow here and say we're going to take out this y right here. We're going to replace it with what this y is equal to. And when we do that, we get a new equation. So I have 3x, right? There's my 3x. I have minus, let me make that a little more clear here. We have minus, and then I have 2. But instead of y, what am I going to put? I'm going to put what y is equal to. Y is equal to 2x minus 7 equals 9. So do you see that right here? I'm going to color it in for you. 3x minus 2. 3x minus 2 equals 9 equals 9. But what have I done? I've replaced the y with what the y was equal to. The y on the bottom was equal to 2x minus 7, and that's what I replaced the y with. All right, so here we go. Now I'm going to go ahead and apply the distributive property here, and I'm going to get 3x minus 4x plus 14 equals 9. Do you see what I did? I distributed, so I multiplied that 2 times that y. Now these are like terms, and when I combine those, I get negative 1x plus 14 equals 9. And now, instead of two equations with two variables, look what I have. I have one equation that only has an x. And hopefully you still have your equation solving skills all sharpened, and you get negative 1x equals positive 9 plus negative 14 is going to give me negative 5. And if negative 1x equals negative 5, positive 1x equals positive 5. So what have I just found? I have found the value of x that's going to make both of these equations true at the same time. But what have I not yet found? I haven't found the value of y. All right, so here we go. But what do I have right here? I have an equation that says, hey, if you want to know what y is, take x, multiply it by 2, and subtract 7. So here we go. I know what x is. Now x is 5. So I'm going to go y equals 2 times 5 minus 7. 2 times 5 is 10. 10 minus 7 is 3. So what do I get? I get 5, 3. What is 5, 3? 5, 3 is the ordered pair that makes both equations true. All right, so I just want to prove to you that it's correct. Let's do a quick check here. All right, I have 3x minus 2y equals 9. 3, but that x right there, I'm going to replace with 5. 3 times 5 minus 2 times what? 2 times 3, and it's supposed to equal, if we're correct, 9. So what's 3 times 5? 15 minus 6, and what do we get? We get 9. 9 equals 9. That proves it works in the first equation. And we already know it works in the second equation because we did it right here, right? 2 times 5 is 10 minus 7 is 3. So we found the value of x and y that make both equations true. So if you take a look at number 2, it's going to be the same thing, except they told us in the top equation what y is. Number 3, the same thing they told us in the bottom equation what y is. But what do we do with an example like number 4? On number 4, they don't tell us what x is or what y is, right? We want an equation that either says x equals, or we want an equation that says y equals, and they didn't give us that. So the bad news is they didn't give us that. The good news is we can get there. All right. So we're going to take one of these equations and we're going to solve it for either x or y. It's our choice. Now I could solve for that first x. I can solve for that first y. I could solve for that first x, or I can solve for that first y. How do I know which one? Well, I want to go with the one that's easiest. And you know what you look for? You look for these variables that have a coefficient of 1. It looks like they don't have a coefficient, but they have a coefficient 1. All right, and it really doesn't matter which one. I'm going to go ahead and go to the second one. All right, so here we have x. I want to get that x by itself. So you should know by now to get something by itself in an equation, you use inverse operations or opposite operations. What is the opposite of subtracting y? It's adding y, right? So I get x is equal to, when those cancel, 3 plus y, or y plus 3. So that second equation, I rewrote now to say x is equal to y plus 3. Well, now we're ready like we were over here. What does the second x equal? Y plus 3. So what am I going to do? I'm going to go way over here to that first x, and I'm going to replace it with what it's equal to. So here we go. I'm going to write this equation down, but instead of writing x, I'm going to write y. Whoops. Let's go back to black, shall we? Back to black. Isn't that a song? Y plus 3. Back in black. That's it. All right. Y plus 3 plus 2y equals 6. So again, I'm going to use my color coding here, right? Can you see the plus 2y equals 6? There's the plus 2y equals 6. Do you see how I had an x there? But what does x equal? X equals y plus 3. So I put it right there. All right, so now what do I have? I have like terms. Y plus 2y is 3y plus 3 equals 6. Now again, what's great, I went from 2 equations with 2 variables, but once I did my substitution, I got just this one variable with just this one equation with this one variable, which I can solve using inverse operations. I subtract 3, I get 3y equals 3, I divide by 3, and I get y equals 1. So again, that's only half my answer. What do I have? I have the y value. What do I not have? I don't have the x value. I need to know the value of x that makes both equations true. I already know it's 1 for y. So I got to go back to my equations, right? Remember over here when I didn't know what y was, I went to the equation that said y equals, right here. I had an equation that said y equals. When I go back here, I don't have an equation that says x equals. But wait, ladies and gentlemen, we created one, didn't we? X equals y plus 3. And now we know that what? Y is 1. So x equals 1 plus 3. X equals 4. And now I know that 4, 1 is the point that makes both equations true. 4, 1 is the solution to this system. And if I were to check it again real quick in that first equation, 4 plus 2 times 1, again, I'm putting in 4 right there for that x. I'm putting 1 right there for that y. And what is it supposed to equal? It's supposed to equal 6. Well, what does 4 plus 2 equal? 6 equals 6. It makes the first equation true. What's the second equation say? We got it kind of covered right here. But what's it say? X minus y equals 3. Well, guess what 4 minus 1 is? 4 minus 1 is 3. It makes both equations true. So again, the method of substitution is using this idea that whatever the top x is, the bottom x is, and whatever the top y is, the bottom y is. All right, I'm going to stop this video here. I think I'm actually going to make 3 videos instead of 2 because I don't want them to be super duper long. So if you understand this method, then you're ready to dive in and do some practice. If you need some more examples, watch the next video. Thanks for watching, everybody.